This lesson will be about the different ways that we could use to solve for the quadratic. When we talk about solving the quadratic equation, what that means is we're looking for x-intercept. Another thing we could say is we're looking for the roots, or looking for the zeros, or we could say we're looking for the solutions. But the main thing is when we have a quadratic, we want to find out what the x is. Many different names, but doing the same thing. Let's look at these two equations. I have y is equal to ax squared plus bx plus c. Compare that to 0 is equal to ax squared plus bx plus c. What's the difference between these? Well, one of the big differences is that in our second equation, we have y is equal to 0. And when we have y is equal to 0, we know that all y's that have a coordinate of 0 mean that it's the x-intercept. Because for all x-intercepts, we are along the x-axis where y is 0. So what we're going to look at in this video is 3 ways that we could use to solve for the x: rearranging and taking the square root, factoring, and the quadratic formula. Now, in the previous lessons, we've looked at the quadratic in vertex form, and we've found the roots by rearranging the equation to solve for x. Before we do that, I want to quickly mention square roots again. So remember, if I have a square root of a negative number or a positive number, they both become a positive perfect square. So let's say I had 5 squared. This is equal to 25. But if I had negative 5 all squared, this is also equal to 25. The reason that this is important is because when we have a square root, we need to always consider the positive and the negative answer. Because if I said, what's the square root of 25? It's not just simply 5, but it's also negative 5 as well. Let's look at this example here from a graphing perspective. If I had y is equal to half bracket x minus 3 squared minus 8, we have a parabola in vertex form. We know that the parabola opens up, and we also know that the parabola has a vertex at positive 3, negative 8. So perhaps somewhere around there. Since it opens up, I would have a parabola that perhaps looks something like this. And we see that there are 2 x-intercepts. So we're not only looking for one answer, but we need to have 2 answers when it comes to finding the roots. Let's solve. Solving for the x-intercept, I need to substitute y is equal to 0. So I have 0 equals half bracket x minus 3 squared minus 8. Let's rearrange it. 8 is equal to half times x minus 3 squared. When we continue to simplify, I'm going to multiply both sides by half now. I'm going to multiply both sides by 2. So 16 is equal to x minus 3 squared. Now, when I'm taking the square root of this, I need to consider both a positive and a negative. So plus or minus square root of 16 equals x minus 3. Now you can think of it like this. Every time you have the square root, you're going to have a plus minus sign attached to it. Okay, so simplified. Our answer, we have plus minus 4 is equal to x minus 3. And now we're going to have two different answers because we have one scenario where we have a positive 4 and we have one scenario where we have negative 4. Okay, so if x is equal to positive 4, we have 4 is equal to x minus 3. 4 plus 3 is equal to x, and x is equal to 7. Hey, we know that one x-intercept happens when x is 7. Our second scenario, we're going to use the negative. X is equal to negative 4. So negative 4 is equal to x minus 3. Negative 4 plus 3 is equal to x. X is equal to negative 1. So here is negative 1. We have two scenarios, and we know that we needed to have two answers because there are two x-intercepts. Let's just quickly do a couple more examples with the square root and the plus minus sign. We've talked about this one already. So when we're doing the square root, we're going to have square root x is equal to plus or minus the square root of 25. So x is equal to plus or minus 5. Now in these three examples, we're going to have to use algebra. We're going to peel away each section until we get to the square root. So let's divide both sides by 2 first. X squared is equal to 98 divided by 2. X squared is equal to 49. X is equal to plus or minus square root of 49. And so x equals plus or minus 7. Once again, another question with algebra. We're going to take the plus 24, rearrange it. X squared is equal to 25 minus 64. X squared is equal to negative 19. Now, we have x is equal to plus or minus square root of negative 19. Put this into your calculator and see, oops, man, I am having some major troubles with my mental math today. Okay, this is square root of 39. Okay, let's take the square root of negative 39. You'll realize that no matter what calculator you use, you're going to have an answer that's undefined. So what that means is there are no roots for this question. So we can't solve this, meaning there are no x-intercepts for this quadratic. Some people have asked, why is it that I can't have a negative square root? Well, by definition, when we are taking the root, we have a number that's multiplied by a root twice. So, for example, 25 is 5 times 5, but there's no number times itself that can give us a negative because we know that a negative number is always created by one positive and one negative. Okay, let's try this example. We're going to do more algebra. X squared is equal to positive 16. X squared is equal to 16 over 9. X is equal to plus or minus square root of 16 over 9. And you can always consider the square root of a fraction as square root of the top and square root of the bottom. So we have x is equal to plus or minus 4 over 3. I'm going to let you work through slides 6, 7, 8, 9, and 10. Pause the video and come back for the solution. Right, here are the solutions for slide 6. Be careful that sometimes you're going to have two answers that are not the same. And so you would separate it so that we have case 1 and case 2. Slide 7, slide 8, slide 9, and slide 10.